Hello and welcome to helpyourmath.com. In this video, we're going to look at finding the average rate of change for any function. First, let's talk about what an average rate of change is. So, breaking away for a second from an average rate of change, one unique characteristic of linear functions is the concept of slope, right? So the slope of a line is the same no matter which 2 points on that line you choose, which is pretty cool, right? Because the slope is the ratio of the rise over the run. And it's going to be the same for any 2 points on a line. Lines are the only types of functions that have that unique characteristic of a slope. However, we can apply that to other functions, only we call it an average rate of change. So for other functions, if we want to find the average rate of change between the 2 points, we find the slope that would connect those 2 points, the slope of the line that would connect those 2 points, and we call that the average rate of change. Just meaning that if you took the slope of every line of the in between those 2 points, you would find their average would be the same as that particular average rate of change, which is kind of cool. So for a line, we have a slope, right? So I have this line here. I can calculate the slope by looking at the rise. So I just went up 1, 2, 3, 4, 5 units, and I went up, so that's plus 5. Over the run, I went over 1, 2, 3, 4, 5, 6. So in this particular case, the slope, we could say, is positive 5 over positive 6 or 5 over 6, right? We usually don't say positive. Well, what about this parabola? So this parabola, if I look at these 2 points at -1, -3, and this point at 5, 2, and I connect them with a line, then I could find the average rate of change between those 2 points. And it turns out that average rate of change will be the same because these are the same 2 points as the line to the left. So I'm just going to label these 5, 2. And we could calculate that average rate of change. So rate of change here would just be the change in y over the change in x for those 2 points. Change in y over change in x, or you can say change in f of x, right? Because sometimes y we call f of x when we're talking about function form. And that would be the average rate of change. So if you're asked to find the average rate of change for 2 points of a function, you must be given the 2 points. A little bit more about average rate of change. That line that connects those 2 points is called a secant line. The secant just implies that it intersects the curve twice, hence the 2 points. So a secant line hits the graph twice. You might have also heard of a tangent line. Tangent lines generally hit graphs or curves in one spot. But here we talk about secant lines. And if you like the formula for the secant line, so m is slope, and this is just indicating that we're talking about a secant line. It would be the output of one minus the output of the other over the 2 inputs. And so we're talking here about 2 ordered pairs. We have x1, f of x1 is 1 ordered pair, and the other ordered pair is x2, f of x sub 2 is the other ordered pair. Okay, let's look at some examples. Find the average rate of change for f of x equals 3x squared minus 8 from x sub 1 equaling 0 to x sub 2 equaling 3. So we have a piece of one point, a piece of another point, but then I actually tell you a little more information here. So what we know is that we have one ordered pair, x sub 1, f of x sub 1, and the other ordered pair is 3, x sub 2, comma, f of x sub 2, 19. So then we could calculate this. Remember, the slope of the secant is our average rate of change. So we would say 19 minus -8 over 3 minus 0. That gives us 11 over 3. So the slope of the secant line between those 2 points would be 11 over 3. More commonly, you're not given the output values, you're only given the x values, and then you have to go in and plug those into the function. So in this example, we have g of x is equal to 7 minus 3x minus x cubed. We have x1 is -2 and x2 is 1. So we need to figure out what is f of x, or g of x1. So g of x sub 1 would be g of -2. So anywhere I see an x, I'm replacing it with a -2. -2 minus -2 cubed. Following order of operations, I can start with this exponent. This would give me -8. So I have 7. I can go ahead and do this too. This becomes positive 6. This becomes -8 minus -8 becomes plus 8. So I end up with 15 plus 6, which is 21. Okay, so what I know here is I have one ordered pair. I plugged in -2. And my output was 21. The next one, x sub 2, would be the same, just same as g of 1. So anywhere I see an x this time, I'm replacing it with a 1. So that's 7 minus 3 times 1 minus 1 cubed. Following order of operations, but also taking shortcuts because I can compute the different terms at the same time. I would have 7 minus 3. 1 cubed is 1 minus 1. 7 minus 3 is 4 minus 1 is 3. So my input here was 1. My output is 3. So now I have my two ordered pairs. I can go ahead and calculate the average rate of change. Remember that average rate of change is equivalent to the slope of the secant line. So this would be 3 minus 21 over 1 minus negative 2. This would be negative 18 over 3. And the slope of the secant would be negative 6. The secant at between those 2 points, that is. Okay, so here's two examples. Pause the video, try these on your own, see how you do. All right, for the first one, we have h of x. Now, well, let's look at it and then we can talk about something weird, but not really. So first we need to figure out what our h of x sub 1 and h of x sub 2 values are. H of x sub 1 is going to be h of negative 3. So anywhere I see an x, I'm replacing it with negative 3. 1/3 times negative 3 is negative 1 minus 5 is negative 6. So here I have the ordered pair, negative 3, negative 6. How about x sub 2? So x sub 2, we're going to plug in 6. So we have 1/3 times 6 minus 5. 1/3 of 6 is 2, and 2 minus 5 is negative 3. So my second ordered pair would be 6, negative 3. Remember that slope of the secant formula? It's just the slope of the line, so we have our 2 points here. Let's go ahead and plug those in. So the slope of the secant will give us that average rate of change. That's going to be negative 3 minus negative 6 over 6 minus negative 3. A lot of negatives here. We want to be really careful. This becomes, or is equivalent to negative 3 plus 6, which is positive 3. Down here, this is equivalent to 6 plus 3, which is 9. And I can simplify 3/9 down to 1/3. Now, if we look really carefully, what do we notice here? There's a 1/3 there. Coincidence? Not really, because that was a linear equation. So all you did was you calculated the slope of a linear equation. Fooled you, unless you noticed that right away. So if you are given a linear equation, you don't have to do the work if it's given in slope-intercept form or if you can identify the slope, because the slope would be that average rate of change. In our last example, we're looking for the average rate of change for f, given x sub 1 is negative 2 and x sub 2 is 0. And I did make a mistake previously, so that's why the screen is now blank. Now, unlike the previous example, you can't just look at the coefficient of x to decide what that average rate of change is. This particular function is not linear, so that won't work. We are going to plug in. So we're going to plug in f of negative 2 for x sub 1, and that's going to give us negative 2 minus 2 over negative 2 quantity squared plus 2. In the numerator, negative 2 minus 2 is negative 4. In the denominator, negative 2 quantity squared is positive 4, because that's negative 2 times negative 2. So we would end up with 4 plus 2. This is a negative divided by a positive, so I'm going to put the negative out front, and we end up with 4 over 6, which will simplify to negative 2 over 3. Looking at x sub 2, we're going to plug in 0 this time, and this will give us 0 minus 2 over 0 squared plus 2. That would be negative 2 over 2, which would be negative 1. To find the average rate of change, now that we have those values, is we basically plug this in like a slope, right? So we're going to say, okay, it's going to be f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1. So what does that give us? That would give us negative 1 minus negative 2/3 divided by 0 minus negative 2. In the numerator, that would give us negative 1 plus 2/3, right? Because minus negative would be positive. In the denominator, we would have plus positive 2. What is negative 1 plus 2/3? Well, that's bringing us 2/3 closer to 0, leaving us at negative 1/3 in the numerator. If you're not a super fan of how I just did that, you could rewrite negative 1. So negative 1 is the same thing as negative 3 over 3, just finding that common denominator with the other fraction. Negative 3 over 3 plus 2 over 3 would be negative 3 plus 2 over 3, and there's that negative 1/3 I promised. So we have negative 1/3 over 2. This would be negative 1/3 divided by 1/2, which would be negative 1/3 times 2, and we end up with an average rate of change of -2/3. So there we have it. These have been examples of average rate of change. Thank you for stopping by.